வந்துருச்சு. லைவ் போகலாமா மேடம்? தம்பி போமா? ஓகே. ஏன் ஆகிட்டு வேடா என்ன தானே பிரச்சனை? திஸ் டைம் பொழுது வந்துடும் மேடம், ஒன்றும் பிரச்சனை இல்லை. நீட்டாக முடிச்சிடலாம்.
ஆனால் உங்களால் வேறு எந்த வேலையும் பார்க்க முடியாது தான் ஒரு மணி நேரம்.
ஆமாம், ஏன்னா அது ஸ்க்ரீன் மாறினாலே உங்களுக்கு இது டோட்டலாக மாறிடும்.
சரி, எனக்கு அதுதான் ஒரு மாதிரி இருக்குது.
ஸ்கின் யூடியூபில்
இந்த வீணாக போன ஓபிஎஸ் மேலே இருக்கக்கூடாது.
இல்லை, வேறு சிஸ்டம் போட்டு வச்சு உட்காந்துக்கலாம் நம்ம இங்கே. ஏன்னா எனக்கு கட் ஆகும், அதுதான் பிரச்சனை. ஏதாவது ஒரு கம்ப்யூட்டர் மட்டும் தீர்ந்து வச்சுட்டு வச்சுக்கலாம். இருக்கிற மானிட்டர் வச்சுன்னு அதை பண்ணிக்கலாம்.
வைஃபை எடுக்கணும்.
இந்த சின்ன டாங்கல் மாதிரி இங்கே தரது இல்லையோ, எல்லாம் கொடுத்தாங்க. இங்கே நெட்வொர்க் இல்லையா மேடம்?
இங்கே கிடையாது,
எல்லாமே இப்போ வைஃபை தான் ஓடிட்டுருக்காங்க.
சாருக்கு மட்டும் இருக்கும்.
சரி, அது வேலைக்கு ஆகாது. நம்ம டிபார்ட்மெண்ட் கொடுத்தாங்களே டாங்கல் எல்லாருக்குமே, சின்ன சின்ன குட்டி குட்டியாக டாங்கல் கொடுத்தாங்க. வாழை வச்சுருந்தானே, கொடுக்கலையா? ஆனால் இப்போ வாங்கின சிஸ்டமில் எல்லாமே வைஃபையோட இதை வாங்கியிருக்காங்களே, ஒரு சிஸ்டம் வாங்கியிருக்காங்க. கன்சர்ன் சார் கொடுத்தாங்க, புது சிஸ்டம் கொடுத்தாங்க இந்த ஆர்என்டியில். அதில் வைஃபை ப்ளூடூத் எல்லாமே இன்பில்ட்டாக இருக்குது, பக்காவாக இருக்குது. இந்த அலோவ் பண்ணுங்களா மேடம்? இதுவே அலோவ் பண்ணுறீங்களா அந்த மீட்டிங்கு? அலோவ் பண்ணுறீங்க, நான் தான் செக் பண்ணுவேன். இப்போ என்ன பண்ணணும் தெரியுமா? இந்த அசிஸ்டன்ட் மேனேஜர் ராமநாதன் கில்லரா? such a wonderful meeting.
Good afternoon, madam.
Good afternoon, sir.
Welcome, sir. Ramanathan, sir. Mute இருக்கு sir.
Good afternoon, sir. Thank you for
Sir, welcome.
Thank you, sir. Good afternoon, sir.
எப்படி இருக்கீங்க சார்?
நல்லா இருக்கு சார். நீங்க எப்படி இருக்கீங்க சார்?
நல்லா இருக்கேன் சார். எப்படி போகுது இண்டஸ்ட்ரி இப்போ ஜியோ டெக்னிக்கல் இண்டஸ்ட்ரீஸ்லாம்?
Cool, sir. We are doing good. We have some handful of jobs as of now.
ஓகே சார். உங்களோட நேச்சர் ஆஃப் ஜாப் என்ன பண்ணுவீங்க?
So basically, we are in KEL India. It's like a global MNC. We are KEL India is a complete subsidiary of that group, KELR Group. So எங்களோட இங்க கோர் ஏரியா வந்துட்டு கிரவுண்ட் இம்ப்ரூவ்மெண்ட் ஒர்க்ஸ், கிரவுண்ட் இம்ப்ரூவ்மெண்ட் ஒர்க்ஸ், கிரவுண்ட் இம்ப்ரூவ்மெண்ட் ஒர்க்ஸ், அதுக்கப்புறம் வந்து பைலிங், ஹெவி ஃபவுண்டேஷன் சொல்லுவோம், பைலிங்.
ஓகே ஓகே.
அதுக்கப்புறம் ரிட்டென்ஷன், எக்ஸ்கவேஷன்ஸ், பேஸ்மெண்ட் எக்ஸ்கவேஷன்ஸ்.
ஓகே.
ஸோ இதான் எங்களோட கோர் ஏரியா ஆஃப் இன்ஜினியரிங்.
சாயில் அவைலபிலிட்டியே கம்மியா போயிட்டு இருக்கனாலதான் நிறைய ஹைவே ப்ராஜெக்ட் எல்லாம் நிக்குதுன்னு சொல்லிட்டு இருக்காங்கல்ல. எப்படி மேக்கப் பண்ண போறாங்க?
இல்ல சாயில் அவைலபிலிட்டி நீங்க எப்படி சொல்றீங்க?
ரோட் ஐ மீன் இந்த ஓவர் பிரிட்ஜ் எல்லாம் தூக்குறாங்கல்ல.
ஆமா ஆமா.
கிடைக்க மாட்டேன்னு சொல்லிட்டு இருக்காங்கல்ல.
இங்க அது ஒரு லொகேஷன் பொறுத்து சார். ஃபில்லிங் அதுக்கு சர்டன் ப்ராப்பர்ட்டிஸ் இருக்கு. ஸ்ட்ரக்சர் ஃபில்லிங் வந்துட்டு சர்டன் இன்ஜினியரிங் கிரைட்டீரியா இருக்குது. மினிமம் பர்சன்டேஜ் ஆஃப் ஃபைன்ஸ் இருக்கணும், இல்ல பிளாஸ்டிசிட்டி வந்து இதுக்கு கம்மியா இருக்கணுங்கிறதுலாம். சோ அந்த மாதிரி நேச்சர்ல நமக்கு வந்து சாயில் அவைலபிலிட்டி வந்து இன்னும் அரௌண்ட் சென்னையில நமக்கு கொஞ்சம் கஷ்டம் தான் நமக்கு மெட்டீரியல் கிடைக்கிறது. இதர் நம்ம வந்து அந்த பேனல் வால்க்கு feasibility இல்ல அப்படின்னா we have to think about the mostly we can அந்த இதை குறைக்கிறது, அப்ரோச்சோட லென்த்தை குறைக்கலாம், இல்ல ஏதாவது ஸ்ட்ரக்சரல் மெம்பர் சப்போர்ட்டோட எடுத்து தான் நீங்க போற மாதிரி இருக்கும்.
நிறைய ப்ராஜெக்ட்ஸ் அப்படியே பாதியில நிக்குது. எப்படி மீட் அவுட் பண்ண போறாங்க, என்னைக்கு முடிக்க போறாங்க தெரியல. 2:30 2 o'clock சார் செஷன் ஆரம்பிக்கிறது.
2 o'clock சொல்லிருந்தாங்க.
ஓகே, டைம் ஹஸ் கம். மக்கள் வந்துருவாங்க. நான் ப்ரொஃபசர் ப்ரொஃபசர் இன் வேல் டெக்கிங். சார்
ஃபைன் சார். உங்க நேம் சார்? சாரி,
டாக்டர் சாம்சன்.
டாக்டர் சாம்சன். ஓகே,
ஸ்ட்ரக்சரல் இன்ஜினியரிங் நான்.
ஓகே சார். ஓகே
ஓகே சார், ஆல் தி பெஸ்ட், கண்டினியூ பண்ணுங்க.
Thank you sir. Thank you for the opportunity.
Thank you sir. Thank you.
So, good afternoon sir.
Good afternoon.
Good afternoon. So once again I welcome all the participants for the second session of this 6-day FDP program. We have with us Mr. C. Ramanathan. Just a minute, please. A quick introduction about our speaker. Mr. Ramanathan is a practicing geotechnical engineer with around 8 years of engineering experience. He has completed his ME Soil Mechanics and Foundation Engineering from College of Engineering, Guindy, the year 2016, and BE Civil Engineering from Congo Engineering College. He has worked earlier in McAfee Environmental Solutions, and now he is Assistant Manager Geotechnical Division in KELR Ground Engineering India Private Limited. He has his expertise in shallow foundation, ground improvement techniques, heavy foundations, ground and rock anchors, and various types of retention systems. Thank you, sir. Thank you for your presence, and thank you for sharing your experiences in this FDP program. Now the session is over to you, sir. Sir, I'll make you as a co-host so that you can share your screen. Okay,
Fine.
sir?
Yeah.
Sir, can you try sharing your screen now?
Just a second. Whether it is visible?
Sir, PPT is not visible, but you have shared your screen. You have shared the group Google Meet. Yes.
Right. Now it is visible?
Yeah, now it is visible. Sir, we can go to slideshow mode, sir. Yes, yes,
Yeah.
sir. Perfect. Please go ahead, sir.
So the session will be of 1.5 hours, and you are planning. We can have some discussion also, right? And that towards the end.
Yes, right. Definitely.
So thank you, Dr. Logeshwari, for this wonderful session of, like, I could see the brochure. You could have brought in some good amount of industry speakers for this faculty development program. And with that introduction, let me introduce one more time to the forum. So I'm Ramanathan. I'm basically looking after the geotechnical designs for the south and eastern part of region in India within Keller. So that's a brief introduction about me. And today, for this particular audience, I would like to present the topic of foundation solutions to address geotechnical challenges. So just I would like to hear from the team, or the forum, whether my screen and the audio are clear to everyone.
Yes, sir, it is clear.
Clear. Yeah.
You are in the first slide. Yes.
Yes. Thank you. So just to have, before jumping in, just like to have a brief introduction about the organization which I am presently working. So it's like we are a Keller group, and we are like a Keller India is a completely subsidiary group of Keller. This is a registered organization in the London Stock Exchange, and we have about 3 major divisions. One is the North America, second is the EME, and then third is the APAC. So India comes under this APAC region, as we have one among the 4 APAC regional units, business units. So India is one among that. And to show about our global presence, we are working in about 40 countries, and about 10,000 people are on with Keller role, and we are presently executing more than about 7,000 contracts every year globally. So to showcase a product range, we are mostly involved into the heavy foundations, ground improvement works, some specialized grouting works like jet grouting, compaction grouting, permission grouting, and several types of rock anchoring and soil anchoring works. And recently we started working in the near shore marine, not a completely offshore, but near shore marine, say for the jetty works, the installation of pilings, jetty walls. So those kind of jobs also we have started picking up. So to give an overview about, this is all about Keller and our presence in the global market. And before that, going further, this is my overview of today's presentation, which I like to deliver to you all. So one is about understanding the various foundation problems. So just a few disclaimer or note, few things most of you might be aware also. So whatever things you are aware, maybe you can correlate with the things what I am presenting, and if anything is new for your you please take it as a good takeaway for your further understanding towards the subject. So we will discuss about the common foundation problems, like simple foundation challenges, and followed by how the ground improvement techniques works to address those challenges. Mainly, I'm concentrating on the vibro techniques, which will have vibro compaction and vibro stone columns, and we'll go through some few case studies as well. And then, since towards as a world we are moving towards a sustainability point of view, I will touch upon the sustainability aspects as a geotechnical engineer, what we can contribute. And finally, I will close it with the summary remarks. So this is all about my overview of today's presentation. And so start with the foundation problems. So, and also if you have any doubts or anything, if you want to, Dr. Logeshwari, whether they can, the forum is open to audio, or we will have the questions only at the end.
It's your convenience, sir. If you want, we can ask the participants to unmute themselves in between and ask the query.
Fine. So they have the audio access as well. Fine. So in case of anything, if you want to have a discussion immediately, you can raise your voice and or you can put your question in during the discussion. Else, we can have cumulatively we can have the discussion point towards the end as well. So starting with the foundation problems, basically we have in broader sense geotechnically we can classify the soils in the two types. The sand and we can say coarse grained and the fine grained soils, and each will have its own merits and demerits. So if you see as something your screen, if you see as the reclamation works, you'll have a major thing. It will be like a loose filling. It's just a end-on filling method will be adopted, and it will be filled over a particular place. So you will have the specific challenges of the loose sandy soils. And if you see our country like India, where you have major coast, most of we have a very greater coastal line, and we all our development projects ports, storage facilities, and even refineries will all be installed on the coastal border of our nation. So those will have some typical challenges of marine deposits or soft clay presence, and in times we have the peat soil as well. So you will have broadly these will have its own merits and demerits for it, and we have to understand how the soil behavior for various loading conditions. So if you, based on the loading conditions and the performance requirement, we can categorize our foundation problems into four major things. One might be the lower SBC of the lower bearing capacity of the foundation soils, and we may face a problem of settlements due to the weak layer deposits. And in case of embankment kind of structures, we will have the slope stability problems. And if it is in the seismically active regions, say something like a north and northeastern part of our nation, we will have the liquefaction problem. If it is a loose sand deposits over there along the alluvial beds also. So broadly, these are the foundation problems which we are going to discuss in today's session. And normally the SBC and settlements, those might be having more clarity. But coming to the liquefaction is just a small video to make you clear what the liquefaction is all about. So you'll be having you can have a structure, and you'll have deposits of loose sandy layer presence beneath your ground. You'll have some loose deposits, and it's in the saturated conditions. So what will happen during the shaking or the earthquake conditions? This pore water pressure will have a rapid buildup and tends to seep out to the surface. It generally try to escape. So during that time, what will happen? The soil turns into liquid medium, and you will have the failure of the structure. So this is all about the liquefaction. And just to people who are not aware of the liquefaction, this is just a simple explanatory video to make you understand or comfortable with the term liquefaction. So what does the industry or the expectations from the geotechnical engineers? They always look for a cost-effective solution. It has to be faster and safer, and recent times for the benefit of the planet, we are moving more towards the sustainable. So these are the most of the expectations from the geotechnical engineers to provide optimal solutions. And coming to with all this background, understanding the problems and keeping eye on the industry expectations, we can have the certain way we can address these challenges by improving the ground. So one such technique is the densification, where we will just try to compact the soil. The other one is the reinforcing, where the soil is not able to compact. You will try to reinforce with a simple way for a better understanding everyone. It's something like how we are inserting a steel into a concrete to make it more tensile to increase its tensile behavior. Similar way, you can introduce or reinforce the ground with some stiffer material, so that the load can be shared in the better way between the stiffer and the less stiffer material. And the other way is the consolidation. So we all know as the coastal soil has a tendency to hold the water within it. So when you apply a load on it, it tries to take the water out from the soil medium, or between the particles, the water trying to escape. but this process needs a load to act on that to extract the water from the holding, like soil bond. And otherwise, you have to have a shorter drainage path. If you are having something, the escape way, it is very near to its particles, then you will have a faster rate of conservation. So that way also we can help in improving the ground, so that your drain, because of this drainage, your shade strength can be increased. And finally is the chemical modification. Say the soil is in one state, with its own chemical or what is it? It's with its own chemical bonding. It may be in certain. It will be exerting certain behavioral aspects. So if you are introducing into with some other material, it will turn into a new material. In that way, the engineering properties of the soil can be modified by introducing some by creating a chemical reaction within the soil and the materials which you want to use. So that is the chemical modifications. So these are the common ways of improving the ground. And today, as I said, we will mostly focus on the vibro techniques. That is the vibro compaction and the vibro stone columns. So just to give a brief overview about the where we can look for the when we go for the ground improvement. It is not like that everywhere we will go for the ground improvement. So we will see how and when we can pitch in there with the we can see the opportunities for the ground improvement. So, in a conventional way, if the load is lighter, if the soil is competent enough, we will go for the shallow foundation. And if the loads are heavy and the structure sensitivity is very high, and you can't afford more settlements, you will go for the deep foundation. These are like two extremes of our solutions, of conventional solutions. There's a shallow foundation and the deep foundation. In between, there is a zone where you can afford for a little bit of relaxation in the settlement criteria, or you can afford more settlements for proportionate of the load. That is a zone which we are speaking the feasibility of ground improvement. So if you see here, so you can see the points number 1 and 2 and the 2 and 2 dash, which speaks about the relative, the load and its settlements. So if you are allowing for more loads with less settlements, obviously we have to go for the pile foundation kind of solutions. And when you have when you can afford more settlements, you can see the settlements value from 2 dash to 1 to 1 dash. If you see the settlements value, the relaxation is a bit more. So in that case, you can look for the ground improvement. And that too, if it is like if the relaxation is a bit less. If the load is less and the relaxation is there, then you can opt for the non-binder solution. That is like a non-chemical modified, rather the vibro compaction or the vibro stone column kind of solutions. And if it is like if you are opting for the need is for more load, then you will go with the binder mixing. So something like chemical modification, I can say deep soil mixing or jet grouting kind of techniques, where you will see the feasibility of ground improvement. So it's just in simple way, if you want to have more load to be taken care by the soil, but you can allow the settlement to a certain extent, the ground improvement is a option which is always available to look after. So that's about how the ground improvement solution will be pitched in the market. So now coming to the techniques one by one, as I said, we will consider the vibro techniques. So what is mean by deep vibro techniques? So generally, it's like it's like a simple expansion of the techniques which we doing on the surface. So normally for the surface compaction, if you are laying a road, everyone might have seen, you'll be having you'll have several layers of let's say subgrade layer will be there, subbase layer will be there, base layer will be there, and the post layer will be there. But every layer will be rolled and compacted. That's we termed as a surface compaction. If the same amount of compaction of the treatment is required, something like a deep down into the soil profile, say 10 meters, 15 meters, or sometimes up to 20-25 meters also. If you want to have that such of degree of improvement, we will opt for the deep vibro techniques. So it depends on the type of soil material. It will be classified into vibro replacement, or the technique can be like a vibro replacement or a vibro compaction. So if it is clean sand is in the sense compactable sand. So the fines content normally we will say less than 75 micron particle size. It has to be less than say 10 to 12% of your composition of the soil. Then in that case, the vibro compaction is the most feasible and the optimal solution we would say. And if the soil has a more fines content, what will happen? Say the presence of silt, even it may not be a purely plastic nature, but if the silt content is more, what will happen? Whatever the energy we are putting forward for the compaction, that will not reciprocate or it will not transfer to the particle to particle. So basically, your compaction effort will go in vain. So to avoid that, it will be always careful to study the suitability of the soil in selecting the vibro compaction. So first, let us we see about the vibro compaction, and later we go into the vibro replacement. So basically, what will does is like, so if you, in simple way, what I can say, if you take a vessel and if you pour a sugar into that, and if you want to add in more sugar into the vessel, what you will do generally, you tap the vessel to make the vessel can take more amount of sugar so that your pocket shall be emptied. So similar way, the soil is there, which is of loose state, and if you are doing with, you are inserting a vibrator kind of material, and you will try to shake the soil basically. So with that shaking effect, what will happen? It densifies the surrounding soils, so that you can have a better compacted ground. So that's what really happens during this vibro compaction technique. So that I will explain here. So this is like a loose stratum. As I said, it's like a initial condition. But when you try to compact that stratum, it will move to a denser configuration. So that either you can, this will be the compensation. This much of sand of volume has been made to subsidized to form a denser configuration like this. So what to do? Either you can have a foundation at this level, or if you want, you can have the surface additional filling from the surface to have the compensation for this subsidized volume. So this is a simple way the vibro compaction shall be explained. As I said, the suitability has to be studied. It has to be in the clean sand range, and based on the soil grades, like you'll be doing the gradation test for the soils, and you can have the D50, D20, D10 size of the soil particles. With that, we can have a quick estimation of the suitability number. If the suitability number is something like 0 to 10 or 10 to 20, it is of a good to excellent kind of soil, which you can have the compaction. And if it is more beyond that, you will have the problematic to compact. So better if it is like more than 30, we generally avoid the soil for compaction, and rather we will think about the other alternate technique to do the same process. So this is a simple explanation video how the vibro compaction technique works. So whether the video is working, you are able to see the animation video.
Yeah, it's working.
Yes. So just to explain the video process one more time. So you will have a crane or a rig machinery, and you will have with the rope hung, you will be having this vibrator. It will have, this portion is a vibrator, and you will have an extension tube from the top. So with this, just to penetrate deep into the soil. So when this vibrator will have this eccentric rotation, there will be a motor which will have eccentric weight. During the rotation of this movement, the oscillation will be generated, and this oscillation will transfer the vibration energy to the soil medium. So this is how it will work. So for the penetration, ease of penetration, the water will be jetting. You will have water jets from the bottom of the nozzle through this portion. Switch to the So you'll have the water jetting from the bottom, and this water will try to make the soil to erode, and it will fall to the bottom. Maybe I will explain one more time. So you can see here the water jets try to collapse the surrounding soil, and it will come to the bottom. And to compensate that, the filling will be done from the top. So the portion around this vibrator will be moving into a denser configuration, which you can very well see the color difference. So this might be the state of the loose initial state, and when we are allowing for the compaction, it will be on the denser one. So what will happen? The engineering properties of the sand, say the shear and the stiffness parameters of the soil, will get increased, and which will be good enough to have a solid foundation for your superstructure. So this is how the vibro compaction technique works. The same has been projected over here. where you can, let me explain one more time. You'll have a water jets with which you will just try to penetrate to the desired depth, where you feel the soil is weak enough, or till when you want to have a solid stratum. So till that range, you will just penetrate with the power of water jets, and with that, what will happen during this process? The water surrounding this soil particles, with the surrounding the vibrator, tends to tends to erode, and it will get deposited in the bottom hole of the vibrator. And this, with the vibrator, it will try to compact. So once we reach the desired depth, this jetty will be, the pressure will be lowered down, or it will be, maybe at times it will be switched off also. And this can provide the compaction energy to the surrounding soils. So it will move to a denser configuration. This is how the overall the soil has been. The overall the soil medium can be improved into a denser configuration. So this is all about the vibro compaction process. We will see some case studies. A typical case study, one of the prestigious case study we have in where the vibro compaction has been successfully employed. We will see about that. So this is for a irrigation dam, ECRF dam, Yethkam Rockville Dam in Polavaram, which is an upcoming dam project, and we are in this project for the past 2 to 3 years, and we are still continuously working towards the development of this project, where we want to have a newly constructed ECRF Yethkam Rockville Dam at this portion, where I am highlighting the cursor. So to develop this cursor, to develop this dam, we'll have to construct a coffer dam. So this coffer dam will be on the upper side, it will be like this, and on the lower side it will have the like this. So this coffer dam will facilitate the dry area for the construction of the dam over here. So what is here the condition is mostly soil, the subsoil condition is mostly sandy in nature, and the challenges what we foresee here is mainly the settlement and the liquefaction. So for that, what we have to do is we have to densify the in situ soil so that it takes the load with a less amount of settlements. And meantime, it will be ensuring the minimum factor of safety against the liquefaction when the earthquake scenario comes. So with all this scenario, the vibro compaction zone, it's like a vibro compaction. The zone will be, the zone has been identified to be treated. And we can see there is, as I said, based on the suitability study, we felt that this portion has to be go on the stone columns, because we have the presence of more silty nature of material, or more towards the clayey nature of soil over here. So where the vibro compaction cannot be directly employed, and hence the vibro stone columns was utilized here, and here the vibro compaction was carried out. And this is the center line of your dam, where you will have a cut-off wall, or you can say plastic D-wall will be installed all the way to a rock bed layer, and then we will have a compaction on either sides of the dam center line cut-off wall. So this is how the vibro compaction solution has been employed for this particular dam construction. As I said, this is a typical cross-section of the elevation view of the dam, where you can see the central core wall, and from here you will have a plastic D wall. We can see plastic diaphragm wall at the center line, and either sides of the area we will be having the improvement of the ground. We will be densifying the ground with the ground improvement technique. So you can see the top width is about 15 meter, and the width is about 445 meter, and to showcase the massiveness of the structure, it's about 320 meters in its across the section. So almost you can see the width of the extension from the center line of the depot. So this mass area has to be treated. So this is the subsoil condition, where you'll have where the condition was more towards the sandy type, predominantly up to a depth of I would say some 18 to 20 meters, and then more towards the rock outcrop, you can see the clay deposits was present there. This is a typical condition of the particular site, and we may need to go all the way where the N values are very high, of very dense range. So that is a minimum requirement for the treatment here. So to give the idea about the site setup, so this you can see here, you can see the line, some rock line you can see in the bit far. So that will be the coffer dams, and the either sides will have the coffer dams. And the center we have the vibro compaction walls being carried out by us. So this just to give, because you are densifying, right? So during the densification, what will happen? The soil tends to move to a denser configuration, and you can see the real subsidence of the soil. So earlier, this might be the person standing over there. That is the original position. And during the after the densification process, this is a particular set of grids, maybe some 9 by 9 in 3 by 3 configuration. Some 9 points has been compacted here, and the resulting subsidence you can see visually at this site. What will happen after this? They will try to fill more amount of compactable sand over here, and they will do surface compaction, so that you will have a solid substratum for the foundation construction.
Ram sir, sorry to intervene. You can just hide that band in the PPT. Hide it.
Oh, this one, sorry.
Yeah, thank you.
Yeah, thanks for notifying me. So this is how the subsidence will takes place. So any job will have we need to understand its efficacy. So it's simple like how we do a cube strength to ensure the strength of the concrete. For the ground improvement also, we should do some post testings, so that to understand or to get the confidence that the ground improvement technique has did its purpose or satisfied its purpose. For that, we'll have the post performance like the penetration test. Either you can do the standard penetration test compare with the pre and post condition, and if you want to have some precise results, then the electric cone penetration test. There is which will give more precise data and consistent data about the soils. So that can be employed here. So here, in our case, this is a ECPT or so for those who are very new to the electric cone penetration, how you do everyone might be knowing the SPT test. To know the soil strength, we will do the SPT test. Similarly, instead of doing the SPT test, we will be carrying out the penetration at a constant rate. You will be with some thrust, you will be pushing a cone, and based on the resistance you are getting from the soil, we will understand its behavior. We will classify its behavior. It is clay or it is sand. That classification we can do it. Also, in terms of strength, like similar to the SPTM, we will get the QC value of the cone tip. So with that cone tip, it will translate into the soil strength in very common way. I'm trying to explain the things over here. So that strength we will compare at the prior to improvement and post improvement. We will compare it over here. So what will happen? This is you can see on the right side, this is the QC value. So as a target value, this is the target has been set to us to ensure that the ground improvement has been worked effectively. So if you see all the graphs over here on the gray scale are the post improvement graphs, and you can see the red line is the average post improvement graph of that particular area. If you could see throughout the depth, it has crossed the minimum target value. And it is also translates this QC value can be translated into the relative density of the soil or the sand. So the criteria range was minimum we should cross more than some 70 to 75% of the RD value has to be achieved. So that is a criteria which has been given to us, and the QC translated into RD values has been shown here. So in any case, the RD value has been more than 75 to 80%. The relative density value has been achieved after the successful treatment through vibro compaction. So this gives a comfort. Okay, whatever we have designed or estimated has been translated effectively into the ground. So hope everyone are in alignment with me till here. Everyone is clear with till here, or you have any doubts, or shall I proceed further?
Please proceed, sir.
Yeah, thank you. So now we will move on to the other technique. That is a vibro stone column. So similarly, as I said, you will have the feasibility study. So if the soil is really compactable, we can go for the vibro compaction. But if the soil is not compactable, compactable nature, we can think for the other vibro solution. There is a vibro stone columns. So we will see how the vibro stone column solution works over here. So in simple way, I could state like this is the in situ ground, and if you have inserting a stiffer material, that is a stone, nothing but stones, we are inserting in certain pattern or in certain spacing. with a nominal diameter consideration. So this much diameter is the stone is going to be formed. So with that, we will be in certain configuration. If you are introducing this stone into the in-situ ground, that is the soil, you will have a composite material behavior. So that is the stone column. That is the ground improved with the stone columns. So what will happen? The initial properties, the C and phi properties initially will have as a composite, when improved with the ground, will have a composite behavior. So that improved properties we will be considering or taking into the design of the foundation or the structure. Foundation design for the structures. So this is how basically the improvement using vibro stone columns works. Okay, so to explain another way, so this is a universal area. If you see the small, if you have 2 by, this is like something like a, I would say some roughly 5 by 5 grid kind of thing. And the columns are installed in the range of 2 meter by 2 meter. The columns are being installed over here. Each column will have its own influence area. So that we will call it as a unit cell area. So here this is a unit cell area. Each packet is a unit cell area. How much percentage of this unit cell area we are replacing with the stones is the area replacement ratio we will term, right? So this area replacement ratio is nothing but the spacing and the diameter. So the spacing decides its influence. So if the spacing is more, then the influence area will be more also. If instead of 2.2 meters center, if it is 2.5, then the influence, then the area the stone column has to cover is bit more. If the spacing is bit less, we can say in other way, the soil is bit weak, and so the influence area of the particular column is bit smaller also. So with this is basically the common term which we will consider to how the treatment is given will be translated into the ground. Generally, the workable area replacement ratio will be in the range of some 10 to 23% or 23%. That is the workable replacement ratios. Otherwise, project will be too uneconomical, or you can't basically form the stone columns because of the so close spacings. We can't form the columns. So the ideal range of replacement will be 10 to 25%. Normally, you can see in any stone column designs, the ideal ratio will be in this range only. In certain exemptions, it may go slightly up to 30% also. So hope I have covered what is the area replacement ratio. And when it comes to the load sharing, this is basically not you are treating as a whole. I would say it's not like a mass treatment. You are inserting certain stiffer material in regular spacing. So the load will, what happens? It will try to share between the soil medium and the stone column member. So whatever the load you are trying to transfer from the foundation, partially it will be shared to the soil, and majorly it will be shared to the stone column. Basically, stiffer material will attract more loads to it. So that's how the stone column load sharing behavior will work. And with this composite behavior, you will take it up for the foundation design. So this is basically the design principle behind the stone column thing. And globally, we will practice the Privé method. So Privé is the one who has given this understanding towards the stone column subject with a composite material behavior. There are several other way of designing also, where in IS codes we will be having like how we design the pile, we will be designing the stone column based on its stone column capacity. So that's also another approach which we have for the stone column design. So like I said, the range of application is more for the vibro replacement. Even it can be used for the sand, where the fines are in the range of more than 10%, 12%, the fines are there, but still we can have this methodology of vibro stone columns. And if it is even into the clay and silt also, you can employ this technique of vibro stone column. So there are two methods on how to carry out this particular stone column technique. So one is like a wet top feed method, and other one is a dry bottom feed method. So design wise it's the same, but the design how it translates into the ground can be employed in two different ways. That is a wet top feed method. That is, you can, from the terminology itself, you can see what is a wet top feed. Wet means we are using water to penetrate into the ground. So similar like how we see in the vibro compaction, to penetrate into the ground, we need the support of water. And we will be feeding the stones from the top. That's why it is called as a wet top feed method. And the other one is the dry bottom feed method, where you will have, maybe I will explain this one completely. So if you see here, as I said, with the water jet, it will be penetrated, and from the top we will be feeding the stones. The stones will be traveling all through the annular space created by this vibrator, and it will reach the bottom. And once it reaches the bottom of this probe, it will be getting compacted. So that's how the vibro stone column has been formed of required. We will be having certain design diameter as well. So based on how much volume it has been consumed for a particular column formation, the diameter can be verified in this way. So this is the wet top feed method is all about. And moving on to the next one is the dry bottom feed method, where again you can see it's a dry, so there is no water will be utilized for this formation, and bottom feeder. So the stone has to be fed directly to the bottom of the hole which we are penetrating. So if you can see, this is like a Keller-made vibrocat, and you will have the vibrator setup over here. So this vibrator will be penetrated on its own thrust and the power of the vibration. Once it's penetrated to the desired depth, the stone will fed to the hopper, and this will take the into the stone tube. There will be all the way you will have a stone tube. Through the stone tube, the stone reaches the bottom. Once it reaches the bottom, it will be compacted in stages. The stone will be compacted in stages. So this is the other way of forming the stone column. So there are several factors based on the soil condition, based on the water availability, and there are so many factors in selecting the particular method of vibro stone column installation. So with that, basically here what happens is the displacement. It's more of like a displacement kind of technique is happening here in vibro stone column by dry method, and more of a bit of a vibro. It's a replacement kind of technique where you will try to wash with the material through the washing, and then you are fixing with the stones. So these are the two slight variation between these two techniques. So hope you are very clear about the type of techniques we can use for the vibro stone column process. So as I said, this will be like a crane hung, and you will be having the rotating motor here, and this water jets will be having through this nose cone. You will be having the water jets. Through this only the water will be pumped, or it will be jetted into the ground to create the cavity formation. As I said, in the dry, you will be having a stone tube all through the from the top to the bottom. You will having a provision to take the stones to the bottom, right? And you will have the vibration, the eccentric weight here to create the oscillatory movement within the particular point. So once this reaches, the stone reaches, you will push the vibrator up and down so that it is getting compacted properly. And like as a pile, we are not forming a pile. Like basically in pile, we can have a very uniform diameter formation, because you are completely drilling a bore and you are taking the muck out, and you will be completely concreting. So the diameter formation will be a bit more uniform in the piling, whereas in the stone column, depends on the nature of your stratum. Your formation of diameter will vary. Say you can see here, it's not a uniform. You can see a slight bulge. In the sense, the soil is weak enough, which is a little bit weak over here. That's why it is consuming more aggregates. And if you see here, it is like a more lesser diameter. In here, which states that the soil is a bit stiffer in nature. That's why the consumption is less. So that's why there is you are not forming a pile. Instead, you are forming a granular column. So which will not have a uniform diameter all the way. So this is a common doubts we'll try to have from the who are from non-geotechnical background when try to put forward this question to us so many times. So this is for the better understanding. So as I said, we have this vibro techniques, right? So one way you can, after the completion of all the tests, we can have the ground testings, like a post-performance testings in terms of penetration test and all. But during the column build-up itself, we will have the real-time monitoring of how the column is being built inside the ground, or how the ground is being getting compacted. So that we will measure a real time. So that will we term it as a M5 record, which is you are seeing on the left side of your screen. So basically, this is an electrical vibrator. What are the vibrator you are seeing, which we have seen in the previous slide? There is an electric vibrator. So it will have its sensors fixed along with the unit. So what it will do from this is like a ground level. So when it penetrates into the ground, it will track the penetration. So this is a depth scale. Whatever you are seeing in the horizontal 0 to 12, this is a depth scale. So you can see the depth, how much depth it has reached. So this is just a verification to the designer or the supervision engineer. So you can see, okay, the column has been designed for so much depth. So we are reaching this much depth. And basically the resistance. So during this, once you reach the desired depth, we are either you are compacting the ground or you are refilling with the stones. So we will know whether really the compaction is being done or not. That is based on the amps. So it's like a amps. It is getting registered over here. If the resistance is more, we'll get the higher consumption of amps. You can see the current amps will be higher. If there is no resistance, it is something like this straight line. Because this point of time, the machine is idle. That's why you are seeing there is no resistance being provided by the ground. So once the stones are being dumped here, and you can see some resistance, that means the compaction is getting carried out each stage. So this is it's like a step-by-step process, which I shown in the previous video. Each up and down movement is getting recorded over here, and the corresponding resistance are being seen here. So this is how on real time you can have the confidence on how effectively the vibro compaction or the vibro stone column has been executed on site. So this is basically you can say a Bible for that thing, or you can say some certification that the column is being installed in the proper way. And post that, we will also do the load test as per the standard way of plate load test. If it is a stone column, we will keep the plate along all covering its influence area. So if, as I said, a column will have its tributary area, which will be loaded. So that will be, because the load will be shared by the soil as well as the stone column component. So the load test will be covering this entire tributary area, and the normal test will be carried out. So just to give a brief background, its application. So like as I said, we can address the settlement problem, we can increase the bearing capacity, we can even accelerate the consolidation. Basically, and to an extent we can mitigate the liquefaction. So it's have its own mechanism. So in case of settlement control and bearing capacity increase, it will act as a reinforcement number. So you will have a additional stiffer material which will attract more load. That's how the reinforcement mechanism will work. And in case of accelerated consolidation, because you are inserting a drainage material which is high, which is have a good drainage characteristics, because stones will have a better drainage characteristics. So which will have which will create a shorter path for the water to escape out. So if you see here, so this might be some clay layer. Okay, so what will happen to have the consolidation? This might be a sand layer, this might be a sand layer. When you apply the load without the stone column, this has to escape either through up or through down. But what we are doing, you are inserting a stone column, so that you are creating a radial path. So your drainage path is anyway the soil will have up and down movements. In addition to that, you will have the radial way of escaping the water. So this is how the acceleration of consolidation process will take place with the vibro stone column. And finally, through the liquefaction mitigation, you have the one thing against the liquefaction is either you have your soil in a more denser way. Say if the soil is loose in nature, then it has to be in the denser state. It has to be improved to a denser state so that your liquefaction will not occur. Other way around, you have to create, because during the fraction of seconds, you will have a huge accumulation of pore water pressure. So that has to be taken out. For that, this shorter drainage path will help you, so that the accumulation of pore water pressure will be reduced, and that also provides a way to mitigate the liquefaction. As I said, the execution parameters like compaction amps, termination amps, column length, diameter, these are the parameters which you have to look on the ground during execution, so that the whatever the objectives mentioned in the top row is getting satisfied. So this is all about the application of vibro stone column. So we have the application part. Now we will go with few case studies which we have on the vibro stone columns. So one area where most the stone columns works effectively is for the foundation, for the tank foundations. So we have several refineries all through the country, and mostly it will be located along the coastal regions of the country. Say right from Paradip, you can say it may be Krishnapatnam, it may be in Tuticorin, or it can be somewhere in the Cochin, or it may be somewhere in the say Gujarat. So if you can see all the coastal and Mangalore to extend in Mangalore, so all this coastal area will have challenging ground conditions, like basically weaker deposits, which will have, because all the ports, the incoming core, the whatever supply we are taking from the crude oil supply we are taking from the external countries, it will be stored here and it will be transferred to the other nations. Or sometimes if you want to export the treated fuels, that also need the storage facilities. So to facilitate this, we will have so many storage tanks being built in the refineries or the marketing terminals all through the coastal borders. So we will have this kind of tanks, and the solution of ground debris is more viable in this for the tank foundations, mainly because for the tanks we have the allowable criteria like something like a 150 mm to 300 mm on the edges, depending on the type of the cone. The allowable settlement range between 150 to 300 mm. That is a performance requirement for the tank cases. And the loading intensity generally will be ranging from say something like as low as 120 or 130 kPa to as high as 250 kPa. That will be the loading intensity. Something like a 15 to 25 meters of storage height, I can say. So in this particular case, it's something like 15 meters storage height. And the tank diameters you can see it's something like a 40 meter 2 tanks, 34 meter 2 tanks, and some 13 meter some 2 other tanks. So these are the tanks which we have treated on the ground improvement with the vibro stone columns. So I explained just now, I explained the performance criteria. So here 180 kPa is the loading intensity of the design loading intensity of the tanks, and the performance because based on the type of I could say how the tanks will be have its roof. So if it is a fixed roof, you can allow settlements. I mean, the criteria allows for more settlements. And if it is a floating roof, basically upon filling the liquid, your roof moves, your roof top will move. It will just float on the liquid what we are storing over here. That is a floating roof, which will have more stringent settlement criteria. So there you will have allowable settlement something like 1 in say less than 150 mm for the floating roof, less than 300 for the fixed roof. So here, as I said, the challenging condition is like at the top we have a densified sand deposits over here. Denser sand. You can see this is represents the finer materials, and this represents the sandy in nature. But as you go deeper, what will happen? Your N value is getting low. It's like a very soft in nature, very soft to soft in nature, all the way till 24 to 28 meters. And if you could see, this is the same. We have carried out the electric cone penetration. As I said, I was explaining previously. So that also states the same. Top you are having the dense sand, and while as you go deeper, you have a thick layer of soft to soft, very soft to soft clay deposits over here, which is evident from both the investigation. That means both the SPT and ECPT are speaking to each other, and we have a great confidence in understanding the type of soil. So, and what will happen? The sand will always exhibit an immediate settlement. So, once you keep a load on sandy soil, it immediately deposits. It will immediately settles. So, that's the immediate settlement. It's the behavior of the sandy soil, but the clay will not settle immediately. It will take some time to undergo its settlements. That's the term we call it as a consolidation. For the load what we are keeping on top of the soil, it will take some time. It is a slow process by which the water slowly comes out of the clay particle, and the ultimate will be the settlement. But this will happen over years. So that's why it has to be always very cautious in handling the clay soils. So we can't be overlooked by seeing the very dense stratum at the top 6 to 8 meters, but we have to really worry about the 20 meter thick clay soil which is below 8 meter. So for that we need the treatment. For seeing the settlements, we need to have the treatment till the stiffer layer. So that's how the vibro stone column has been employed. In, say, as I said, the maximum range was 33%, and the minimum for the smaller tanks was about 18%. We have formed about 800 mm to 850 mm diameter of stone column, all the way up to the 32 meter deep. In fact, this is the deepest stone column for a record in India, beyond which no stone column has been carried out so far. So this is a site setup where you can see the crane. This is based on this method. This improvement was done using wet top feed method. You can see the vibrators, and with the support of water, it has been penetrated to the ground for the formation of vibro stone columns. This is a typical M5 record of the vibro stone columns. As you can see, we can reach almost like 32 meters. This is a scale of 40, and we have reached about 32 meters over here. And then this is the washings, basically to create annular space between the vibrator and the soil, surrounding soil. Then only your stones will flow through this medium. So this up and down movement is called washings. And once we reach the, we have sufficient washings, we will feed the stones from the top. So from here onwards, you can see the compaction, consistent compaction effect seen witnessed over here, and the column has been formed successfully. And for the post performance, we will have tested with the load test. So this is the completed view of the tanks, where the tanks has been completed and it has been handed out for the superstructure erection of the, you can say, this kind of steel elements will be placed on top of this to form a storage tank on top of data ground. So moving on to the next case study, this is for a food production manufacturing plant in Assam. So Assam is like a seismically vulnerable zone, high risk zone. So here the problem is the liquefaction. So it's about 40,000 square meters of area. The plant is supposed to be established, but they can't take chances with this seismicity. So they want to go look. They were looking for some ground improvement. And in addition to complicate the problem, they have a very soft to medium stiff clay layers at the top, and then the liquefiable sand layer at the bottom. So it's not one problem, it's really two problems. The problem of settlement and bearing capacity with the clay layer, and the problem of liquefaction with the sandy layers at the bottom. So these two has to be addressed. So again, the criteria was something like 100 to 140 kPa was the loading. Here, almost all the foundations were of shallow foundations, and so the settlements were a bit, as per IS6, they were allowed only up to 50 mm. But these were for the raft is about 75 mm. But these were on the long-term perspective. So once the structure is during construction stage, the settlements will undergo. But because of no external connections, it's still allowable. But once the structure is completed or it is into the surface, you can't allow more than 50 mm or 75 mm for the given load of 100 kPa and 140 kPa. And seismically, we have to design for this is the most stringent seismic criteria we have in India. That is Assam region, something like Assam and North Himalayan regions will have this criteria. It's like it will be categorized under zone 5 with a BGA of 0.36 and magnitude in the range of 7 to 7.5. So your factor safety against liquefaction has to be greater than 1. So here we have proposed some innovative solution of having a vibro compaction and the vibro stone column. So vibro compaction, you will do it for the bottom half of the portion, and the vibro stone columns we will do it for the clay soil. Because the sandy soils, we found it's very clean in nature, and so it is compactable. So we will instead of the same instrument will be the same material. Setup. It will go through the bottom. It will compact the bottom soil, and then when it reaches the clay stratum, you will do how you will form the stone column. The same way the stone column will be formed. So it's an innovative approach we have adopted here to pass on the benefit of optimization to the client, so that they will be really financially they will be happy to see the reduced cost of the project. So this is all about the solution which we have employed for this food production facility. So here the maximum ratio was about 32%, and the depth of treatment was almost like 20 meters maximum we have went. 16 to 20 meters the depth we have treated here. And as I said, we will do the post penetration test, where you can see the red color one is a pre-ECPD and the green color one is a post-ECPD. And you can see a good improvement in the post-improvement results. You can see the difference, the bandwidth gap between the red color one and the green color one. You can see good amount of improvement over here. And in addition to that, for the columns, stone columns which is coming on the top, we will have the load test as well. So it will be a plate load test which will be of single and group column. So this smaller scale loads were of single column load test, and 3 or 4 columns will be tested for the group column load test. So this is how the plate load test has been carried out successfully for this job site. So these are some of the few construction site photos where the stone columns will be, the ground will be improved with the stone columns, and you will be having the foundation construction on top of that, and so followed by the superstructure construction. So moving on to the another case study of railway embankment. So this is a very interesting case study where you have to, this is for the station like a line doubling, basically tripling of existing railway alignment. So it is in Andhra Pradesh, where you have the like the soil type is something like a sandy clay in nature, which is of again it's of soft to medium stiff nature for the top 10 meters, which has to be improved. Otherwise, the stability of the embankment, to ensure stability of the embankment, this ground has to be treated. So you can see the this is like a existing alignment, and you want to have a new alignment with the improved speed. So then we will have some speed restriction over here. To have the proper stability with the higher speed, you will be having a they have proposed the vibro stone column to improve the ground in this weaker profile, weaker sections. So here we have carried out the vibro stone columns next to a running line. This is a live line that where every day you have so many trains. It's a busy route basically. So many trains will be passing here and there, and you will have to do the execution of works very closer to this working railway line. And here the depth of treatment is something like 12 meters, and 18% area replacement ratio has been adopted. So again, this is a drive method which we employed over here. So this is a real-time monitoring data where we are having the clear-cut compaction achieving each stage, and the stone column, the load test also has been carried out here. So this is a side picture where you can see our rigs are performing the stone columns and next to the railway line. So moving to the final case study, one more case study is like a mounted storage vessel. So again, this is a very common. So storage of fuels will happen in terms of circular tanks, and if you are like some inflammable materials, more inflammable materials, they will be using the this mounted storage vessel. This is very safest mode of transfer. Storing the LPG. So these particular facilities is for a marketing terminal, for the Indian marketing terminal in Chennai, where you will have this something like where you are getting our domestic gas supply. So this is a place where you will have the LPG gas will be getting stored over here, and this will be filled in your cylinders, and you will get at home. So this is for the storage facility. So here it will be on a spherical members will be embedded into the soil. So this is a ground level. You can see the screen. This is the ground surface, and top of that you will be creating a mound, basically a soil mound. And within the soil mound, we will be embedding this bullets. This we will call it as a bullets, and this bullets will have nothing but steam vessels. It's something like it looks like something like a petrol. Like you will be in roads, you will be seeing the petrol carrying vessels, the lorries and all. It will be of bullet in nature. So those kind of larger bullets will be embedded into the ground, and it will be covered. So for a safer storage of the inflammable materials. But the performance requirements will be very stringent for this particular mounted storage vessels. So here the problem is with we have a loading intensity of close to 160 kV as a loading intensity, but we have 8 to 9 meters thick deposits of soft clay. You can see here the color. The green color indicates the clay nature and the yellow color is the sandy nature. So here the problem is mostly the predominant governing problem is the settlements we are expecting from the weaker clay layers, and to extent because of the recent upgradation in your seismic codes and even this seismic even though if you are in Chennai, but if the sands are a bit loose in nature, with the guidelines given as per the codal provision, this falls under the zone 3 category and which tends to liquefy during the seismic event. So the problem of settlement and the liquefaction has to be addressed by the ground improvement solution, what we are proposing here. And moreover, as I said, this is you can say here the concept of reinforcement as well as the consolidation will be effectively utilized here, because the estimated settlements for this thick soft deposits of clay layer is very high. At the end of the day, we can allow only 50 mm during a service state. If you could have ion here, so during the service stage you can allow only 50 mm settlement of the structure. But the estimated settlements is something in the range of 200 to 300 mm even after the improvement. So what we have carried out is the preloading. So we have kept a partial load of the future loading intensity. As soon as we treat the ground, we have filled the ground with say 60% of the future load has been made into a soil mound, and this area has been preloaded before the construction of the structure. So once this preloading is done, and if you are satisfied with the settlements, if you are satisfied with the degree of consolidation of that particular of the soil for the given loading intensity, then we can allow for the construction of the mound. So it's like doing the things in stages. So you will take the ground at the first instance, then you will load it with the dummy load. There is a preload surcharge, and then once the settlements are as per your expectations, you will take out that surcharge and you will start constructing the original structure, so that you are eliminating the risk of lateral the settlements in later stage of the structure. So this will be giving you very high confidence on future settlements. So this you can see. So this is this what I can say. This is the final results which we have taken during the final hydro test. So since even though we have estimated roughly about 200-300 mm during the initial stage, but during the we will say leakage test, before the operations they will carry out this hydro test, and during the hydro test the settlements were in the range of 30 to 70 mm. This is the maximum possible load, because the leakage test will be always carried out with the water, but the actual fluid will be like a gas or some other fuel also. It will be 0.5 times or 0.6 times the unit weight of the water. So the actual load will be lesser than the water load, and for the water load itself, the maximum settlements were 30 to 60 only. So these settlements, what you are saying is prior to the connections. So once this hydro test is done, then starts your service time, and from there onwards you are allowed only to 50 mm. So this is how the soil behavior with respect to the loading intensity has been carefully studied, and the solution will be employed, and it will be cater the needs of the future performance. So this is the photo of the preloading stage, and this is the final constructed mound during the hydro test. So this is all about the solution which I like to state it here about the vibro techniques. So just going way forward, we are moving towards into a new world of, like I could say, like more of sustainable things or sustainable visions. So just to give a brief view about sustainability point of view, I'd like to spend another 10 to 15 minutes in this aspect as well. So as I see, the pollution, the emissions, basically the carbon emissions is getting increased day by day. You can see over a larger period, the last 60 to 70 where the industrial revolution has been taking place, we could see more increase of carbon emissions. And we are in like about 7% of contributor for the global carbon emissions. So how this is like a carbon cycle. So how it all, this is a carbon cycle from where it originates and from where till where it will end. So what we'll do, we'll try to extract the raw materials, we'll transport it, we'll manufacture in some plant, and then transfer the final product to some other construction material. So that construction material will be getting used, and then during the operation of the construction material, you will be emitting more carbon. And finally, once it's done its service period, it will be demolished, and then it will be filled in somewhere. So this is how the complete the carbon cycle of the construction industry will looks like. So basically, it's something like a amount of carbon which is being emitted during each and every stage. That's why we refer as a CO2 emission, carbon emissions. So why it is very important? Because we are using a material like a cement and steel, which is more unavoidable for our construction industry. However, there is a major contribution of the contributor for the carbon emissions. So cement and steel put together, it's almost contributes 16% of the carbon emissions, CO2 emissions per year. And if you say 1 ton of steel, it will emit almost 1.85 tons of carbon CO2 emissions. But you will be really shocked to I would put forward the other number to rectify the impact of this one ton of steel. You need a forest of 2.4 acres to be formed with the fully grown trees, not a smaller tree. It has to be fully grown trees to cater the or to compensate the emission of this 1 ton of steel which is going to be made. Imagine how much tons of steel we are speaking or dealing with every day across the country for a construction industry. So that's why it's really a threat for our future. So as a Keller, we have 3 main objectives because the UN has set almost 17 sustainable goals, parameters, out of which we have taken like a planet, people and principles as the 3 major goals, and carbon footprint reduction will come under the planet. That's why our interest towards the planet. So in what way we can contribute to the reduction of carbon. So these are the basically the carbon, it will be studied under 3 scopes. One is the scope 1 is the direct scope. That's what are the during construction time, what are the emissions you will take from the fuel consumption, machineries. So that all will come under scope 1. And indirect emissions is something like what we are dealing with the saying if you are in office space, right now we are in a closed environment, but I'm using the light, I'm using the battery power for this presentation, and I'm using the internet power for the internet office space. So everything will come under the scope 2. But the contribution from the scope 2 is very little when compared to the scope 1. But when compared to the scope 1, scope 3 contribution is very high. So this is a major contributor. This comes from the material, something like a cement and steel. This is the scope 3 of carbon emissions. So these are how the carbon is categorized by the global committee, and we are looking to how the stage each scope we can reduce the carbon that we are working out. So these are like a carbon hierarchy. The first and immediate way is eliminate. So if we have a chance to eliminate the particular, say if I am saying steel and concrete, mainly it will be a major component of the piling. If by doing ground erosion, if I can eliminate the piling, it's well and good. So I am directly eliminating the footprint. Another way, if I can't avoid the piling, so I can reduce how much optimization really this much diameter and this much length is required, or I can have any optimization in the design so that I can reduce the contribution of the cement and steel over there. In other way, if reduction is also not possible, you can substitute. Say instead of normally the OPC cements which will be often employed, whether the OPC can be compensated with the slag cement, which will be generating from the recycled materials. Even the steel also at times it is coming from as a recycled material, not the raw steel. Instead the used materials has been recycled and it has been reused for the construction purpose. Whether that kind of substitute can be made for the construction. So that's how substitution work. And finally, if no other things are helping, we have to compensate. Say either like planting trees or buying some carbon credits. A lot of carbon credits has been working globally. So we have to deposit some amount and they will, but this is like a final thing which we, like not every single person can accommodate, but to a possible extent we can concentrate, eliminate, reduce and substitute. But these, even it need not be in our construction activities, I would say, even in we can practice effectively in our regular day-to-day life as well. So if you are going out, everyone used to say, just switch it off the fans or lights when you are not inside. So that kind of simple practice of living, of our way of living, can help in reduction of carbon. So this is just a small comparison which we practically we have executed. Say for a particular tank, when it comes to us, it is proposed on a pile foundation. But seeing the geotechnical conditions, we given a thought, instead of board piles of so and so length and diameter, we can optimize with the vibro stone columns or the vibro techniques, which are more sustainable in nature. So if this will also have certain amount of carbon emission, but you can really compare the scales, how much this emissions is going to take place and how much this will consume. So based on that, we can provide a better solution. So in our case, this is a pile foundation, and you can see the carbon emissions in the range of 12,000 to 14,000 tons of carbon emissions. And put together all the primary and secondary source, we are resulting with 21,000 metric tons of carbon emissions. So we have employed an environmental engineer for this particular activity, who will help us in estimating the carbon. We have a carbon calculator, which everyone can also can download from the internet, the carbon calculator, and he will support us in estimating the carbon emission for each and every product which we are going to use in the ground. So based on the workings, it is estimated about 21,000 metric tons of carbon is being seen from the pile foundation. But for the similar one, when we if it is really feasible, in our case it was feasible with the ground improvement. So with the ground improvement technique, we found the amount of carbon emissions is very meager, say mere 803. It's not even close to 1,000 metric tons of carbon emissions, because the main thing only the stones and the installation point of view. These are the other resources we need. So with this, we could effectively reduce the 95% reduction we have witnessed in particular project. But this may not be, like, I can't say everywhere this use of ground improvement will have 90% reduction, but definitely it will have some significant reduction when compared to the piling and the ground improvement. So this is the one way which, because mainly the geotechnical engineers, we are the first one to hit the ground. So we have a larger vision towards how effectively we can plan and provide a sustainable solution for the future. So this is in our hands, which you can take it along with us for the better future. So to summarize it, like we have seen the foundation challenges and different types of common foundation challenges for the structures, and how the vibro techniques can be effectively utilized to provide optimal foundation solutions. And even if you have a very confident soil investigation, reliable soil data, you can really do a optimal design solution, which will result in good amount of savings in both cost and time. And further, in terms of sustainability point of view, if you use some native materials, it will have a greater influence in the carbon reduction. There is a recycle, or you can say as alternate materials. If you are thinking, you can reduce or eliminate and recycle the materials. It will have significant reduction in the carbon footprint emissions. I mean carbon dioxide emissions. And finally, like we civil engineers are challenged to ensure the future with the right foundation technologies, with us incorporating sustainable future. So with this, I would like to conclude my discussions or the presentation. The forum is open for first of all, thank you for the patience listening. I don't know how much value I could add for your through this session. So if there are any questions, you can feel free to ask me. If I have an immediate answer, I will respond to you. If not, also don't worry, I'll do my checking and we'll get back to you for sure. So that's a vote from my end.
Thank you, Mr. Ramanathan. The presentation was elaborate and with a lot of real-time examples and everything. It was very good. Now the session is open for discussion. Participants, you can have your discussion here.
I'll just stop share my screen so that I can...
Yeah, sure.
Yes.
Is there any query from the participants, sir?
Hello, sir.
Yeah.
Yeah, this is Nivedita. Actually, during sometimes before we faced a problem, that the structure